concepts we're working on or any of the textbook assignments. So I remember early on, I said, I hadn't done a 122 remotely before. And so timing, there may be days where I run long and there may be days where it feels short. But one of the things I have tried to build in is time for you to ask questions if you have them. And I think what happened last week especially was there just weren't that many questions because you were doing really well with the content. And that's just fine. But I don't want you to be shy about asking questions. I want you to take advantage of that time if you do need to ask questions, because I think that's probably how a lot of our class sessions will go. I'm completely fine with that, but I do want to make sure that you know that time at the back end is there for you to ask questions if you have them. All right, let's talk sequences. There are going to be two types of sequences that we are going to focus on, and the first of those are called arithmetic sequences. And rather than me just telling you what that is, I think you're going to be able to determine what that is by looking at an example of one. So if we look here at that following sequence of numbers, 2, 5, 8, 11, what do you think the next term would be? A couple of 14s, lots of 14s. Excellent. How'd you get to 14? What did you do to land on 14? And, a bunch of you can type it, that's fine. Plus 3, add 3. Moylan, add 3, add 3. Excellent. So what you recognized was to get from one term to the next, what we're doing each time there is we're adding 3 every single time to get to the next one. So the next term would be 11 plus 3 or 14. You're exactly right. And in an arithmetic sequence, that's how we get to the next term, is by adding or subtracting the same number every single time we move one place along the line of numbers. So with that in mind, a question might be posed that says, what's the 20th term? And some of you who are grinders will just start listing them out until you get to the 20th. But really, that question is kind of a setup. We're not going to really list them all the way out till we get to the 20th term. Instead, we're going to look for a formula for an arithmetic sequence. We're going to look for a formula for an arithmetic sequence. And what we're going to look for is a formula for the nth term. So it's a formula that no matter what one I ask for, if I ask for the 20th, or I ask for the 30th, or I ask for the 73rd, it doesn't matter. This formula is going to work every single time. That's what we're going to come up with, is a formula that would give me the nth term of an arithmetic sequence. So I'm going to start out with n equals, because I'm looking for the nth term. And the way that this formula is going to work is I'm going to start out with the number at the beginning of the sequence, and we're going to call that A. A is at the start of the alphabet, so A is at the beginning of our sequence. We're going to call that A. Something that you determined was to get to the next term, I need to add 3. So what I'm going to need to do here is I'm going to need to add 3. Right? If I start out with 2 and I add 3, I get to the next term of 5. If I add 3 to that, I get to the next term that's 8. And that's how this works. Now, the big question is, the difficult question is, the fun question here is, how many times do I have to add 3 if I want to get to the 20th term? So for right now, let's think about this 20th term part. We'll come back to the nth term in just a minute. If I want the 20th term, how many times do I have to add 3? Outstanding, Leslie. Very good. Courtney, think about that for a minute. If I start here, to get to the second term, I add 3 once. To get to the third term, I added 3 twice. To get to the fourth term, I added 3 times. Awesome. Very good. And hopefully Isabella, you're with us too. So if I want to get to the 20th term, I'll need to add 3 19 times. And so my formula to find the 20th term of this particular sequence is going to be, well, let's see here. If I want the 20th term of this sequence, I'm going to start at 2 and I'm going to add 3 19 times. 19 threes plus that 2. So let's see, if I do 19 times 3, that's 57. And 2 plus 57, the 20th term would be 59. And I didn't have to list them all out to get there. You could check our work and see if it's right. But that's how we get to the 20th term. Now let's write that formula for the nth term. So the nth term is going to be a, the term that I start with, plus. Now for this particular formula, it was 3. We were going to add 3, but it's not always going to be 3. Instead, we're going to call it D. And what that D stands for is the common difference. The difference between each term, how far is it between each term, that common difference. When we have that, it's the same every single time. That's how we know we have an arithmetic sequence. And so we're going to have that D. And then this is a little bit of a tough one. We'll see if we get there on this. When it was the 20th term, I needed to do that common difference 19 times. When I'm looking for the nth term, how many times do I have to do that common difference? And it's not going to be a number answer. But if I'm looking for the nth term, how many times do I have to do that common difference? And maybe I can lead you a little bit. When we wanted the 20th term, we had to do 19 common differences. Not quite, Courtney, but you're on to something with the subtraction. So if I wanted the 20th term, I needed to do the common difference 19 times. What if I wanted the 40th term? How many times would I do the almost? Okay, I like the -1 very much. Not quite D minus 1. If I want the 20th term, I need 19 times x. If I want the 40th term, what do I multiply by x? Or how many times do I multiply the difference? If I want the 40th term, how many differences do I need? $39. That's right. And what if I wanted the 54th term? How many common differences would I need? 53. Excellent. Okay. So this time I'm looking for the nth term. So I want you to use the same logic you did to get here, the same logic you did to get here to tell me how many times we're going to have to multiply by the common difference. The term -1. That works, Courtney. What we're after is n minus 1, right? The 20th, we need 19 because 20 minus 1. The 40th, we need 39 because 40 minus 1. The 54th, we need 53 because 54 minus 1. And if I'm looking for the nth term, I need to do that common difference, n minus 1 times. So what we're going to have for our general formula for an arithmetic sequence is the nth term is always going to equal the starting point, which we're calling A, plus the common difference, whatever that might be for that particular sequence, times n minus 1. And the reason that the formula looks that way is because if we're after the 43rd term, then we need 43 to get plugged in here, and then that's going to be 42 multiplied by the common difference. So it's however many times we're going to do the common difference multiplied by that difference added to the starting point. Right here is our general formula for an arithmetic sequence. It's a little abstract. N minus 1, not something that we're that used to dropping into a formula, but I'm going to have you try some stuff with sequences. We're going to do a lot of practice today to get comfortable. First and very quickly, just a poll for us. What is the next term of that sequence? And you could probably type this one faster, come up with the answer here faster than I can make the poll. But that's all right. I just want to do a poll and make sure we're comfortable with it. What is the next term of that sequence? A little bit of vocabulary here too. When we see next term, we want to make sure we know what that means, what it is we're looking for. We'll do another 15 seconds and then talk about this. All right, not quite unanimous, but close. Let's take a look at what we've got here. I think one of the things that people answered is very much related to the answer here, and that's a definition type thing. So we're after the next term. So we look at this and what we see is, well, it went up by 7, it went up by 7. So my common difference here is 7. What that means is to get to the next term, I need to add 7 more. The next term will be 25. And that's how an arithmetic sequence works. We're either going to add the same amount or subtract the same amount. They could get smaller every time we move over one term. Okay, now for a little bit tougher. Find the formula for the nth term of the sequence. And I'm not going to set up a poll for this, but I am going to pause here for a little while and let you try it, keeping in mind that our generic formula for the nth term is n equals a plus d times n minus 1. One of the things I want to mention, if you remember back to your algebra classes, you would see equations of a line that might be like y equals 3x plus 7. And one thing I want you to notice, the reason I bring this up is the y and the x, they had to stay in there, because those were the variables we were using to write this equation. Not everything was going to be a number. We were going to have variables in our equation. And the same thing is true here. N is the nth term. And so those n's, both of these n's are going to stay as a part of our formula. We're not going to get rid of those. All we're going to do is replace the a and the d with the appropriate numbers, and that's what's given us our formula for the nth term. So once you realize, hey, I've got an arithmetic sequence, and an arithmetic sequence means I'm looking for something set up like this, and I know that n is going to stay in there. The only things I'm plugging in for are the a and the d. And when we do that, let me know if you have trouble with this or you're not sure where it came from. But our formula for the nth term of the sequence now will be n equals a, which is my starting number. So that's the 4, plus d, that's my common difference, which here is, let's see, it was 7 each time. Yep. So that's 7. And the n minus 1 is just going to be a part of my answer. And so the formula for the nth term of this arithmetic sequence looks like that. 4 plus 7 times n minus 1. Are there any questions on what we did to get that formula for the nth term? Excellent. If you're asked for the formula for the nth term on a quiz or an exam, that's what your answer is going to look like. There are some of you that may want to think, well, couldn't I simplify this by using distributive property and then cleaning it up after that? You could, and it's not really wrong to do that, but there's an advantage to leaving it in this format. when we see it in this format, we get information. We get what the starting number is, and we get what the common difference is. If you simplify it by using distributive and combining like terms, we lose that. So leaving it like this is the best way to go ahead and format an answer if you're asked for the formula for the nth term. If we were asked for the 33rd term of this sequence, we would just say, well, the 33rd term is going to be 4 plus 7 times 33 minus 1. And the reason I do this is to sort of illustrate how that minus 1 really works in case it's a little fuzzy, this whole idea of n minus 1. Okay, so I'm starting with 4, and I need to do 7, 33 minus 32 times. Oh, right, because I'm getting to the 33rd term, so I start here, and I do add 7 32 times. That'll get me to the 33rd term. That's why that minus 1 is in there. That's what it does for us. So 32 times 7 would be 224, and so the 33rd term of this sequence would be 228 if we were asked for it. I certainly don't want to list them out to the 33rd term, but that's what we would do to get a formula for the nth term of an arithmetic sequence. Our general format looks like this, and the way that we write one looks like that. Are there questions about coming up with a formula for the nth term of an arithmetic sequence, or what an arithmetic sequence is? It's when we have a common difference between the terms. No, you don't have to memorize it, Leslie, because when you take your exams, you're allowed to have one page of notes front and back with whatever you want on there. And so while I won't give you that formula during the exam, you can certainly have it on your paper. I would, absolutely. Great question. Excellent question. I think it's very good to be thinking about, hey, wait a minute, am I going to have to memorize that? This is perfect, perfect. Another type of sequence that we're going to look at is called a geometric sequence. So let's look at this sequence down here, and I'm going to ask you again to tell me, what's the next term? We'll start out with what's the next term, and then we'll talk about how you got it. There's a little bit of pattern recognition that goes on with sequences, which is why it's a great elementary school topic. You know, we're going to do something a little higher level than just recognizing the pattern, but that's where this starts, is with pattern recognition. All right, I've got some 48s. How did you get 48? Times 2. Great, Courtney. Moylan, I'm sure you're right there with her. If not, I'll pause for a minute, but yep. As I look at this, my first thought is, well, let's see, add 3, then add 6, then, oh no, wait, it's not the same thing every time. This is not an arithmetic sequence. It's not that type. Okay, so instead of adding, what if we multiply? Hey, multiply by 2, multiply by 2. All right, I found it. We're multiplying by 2 every time to get the next term of 48. Perfect. When we had an arithmetic sequence, that was when we add or subtract the same number every time down the line. A geometric sequence is when we're going to multiply or divide by the same number every time. So here we are multiplying by 2. When we did an arithmetic sequence, we had a common difference. Now what we have is a common ratio. The ratio between the numbers. If we put 6 over 3, we would get 2. If we put 12 over 6, we would get 2. If we put 24 over 12, we would get 2. So it's a common ratio, and we're going to call that R. If we want the 20th term here, we don't want to list those out. Instead, we're going to look for a formula. And let's do that. Let's do the 20th term. So, okay, I started out with 3, and then I need to multiply by 2. How many times do I need to multiply by 2 in order to get to the 20th term? Same logic as last time. Excellent, Leslie. Very good. Very good. And a string of 19s would have been just fine there, but if you're all happy with the 19, that's great. To get to the 20th term, I need to multiply by 2 19 times. Now I could do 2, 3, 4, 5, 6, but that's pretty clumsy. Instead, what we're going to do is we're going to just use an exponent. So I need to multiply by 2 19 times, and that needs to be multiplied by 3. This is going to be a pretty big number. I'm not sure I'm going to use it. 2 to the 19th, well, it's not as big as I thought, is 524,288. And then we multiply that by 3, and we end up with, what, 1,572,864. So the 20th term would be 1,572,864. I definitely didn't want to list them out all the way to get there. You probably know where this is headed. We are going to come up with the way to write a formula for a geometric sequence. It's still going to have n. It's still going to have a. A is still the number where we start. But this time we're going to multiply by the common ratio. And then here's a really important question. I'm going to have an exponent up here. That's the number of times I need to multiply by the common ratio. What's that exponent going to be? If I'm looking for the nth term, how many times do I need to multiply by that common ratio? Excellent, Courtney. Very good. That's fantastic. Nice work. And n minus 1 is going to be our exponent. And typing, that's a little tricky, right? Because when you're typing in a straight line, you're kind of restricted. We want n equals a times r. And then if I was going to be nitpicky, Courtney, and I won't, and I'll cut y'all slack on this on the quizzes also. If I was going to be nitpicky, we want to raise it to the n minus 1 power. Yep, you got it. Very good. If I was going to be nitpicky, we need parentheses around there because technically without the parentheses, what we're saying is we're going to raise, we would do the exponent first, then we would multiply, and then the last thing we would do here is subtract 1. When you type this, I'm going to hope that you put parentheses around your n minus 1, but if you don't, I know what you meant, and I'll give you credit for it if you email me. All right. So that's one of those things where if you were writing this down on paper, it would look like this, and there'd be no mistaking that you meant to put the 1 in the exponent. Technically, it should be like this. I'll just tell you, if you type it on a quiz and you type it that way, Canvas is going to mark it wrong because it's looking for, well, this says you're only raising the r to the nth power. If you email me, I would give you credit. But the parentheses are better. That was excellent, Courtney. I'm thrilled that you gave that a shot. That is fantastic. Our formula for a geometric sequence is going to look like this right here. So when we write a geometric sequence, we're still going to have a starting point that we call A. We're not going to have a common difference. Now we're going to have a common ratio, and that gets raised to the n minus 1 power. Any questions about that before we do a couple geometric sequence questions? Fantastic. Okay, find the next term of this geometric sequence. I don't expect this one to be hard, but I just want to make sure we're on solid ground and we know what the next term is and we know how to find it. So we'll set up a poll here. For what's the next term in this sequence? We'll go another 15 seconds and then talk about it. All right, unanimous. Very good. We've nailed it with the next term and the geometric sequence. And what we're looking at here is we have to go find that common ratio, multiply by 3, multiply by 3. And so we'll multiply by 3 again to get the next term. And so 54 times 3 is 162. So the next term in that sequence is 162. Just like we did with arithmetic, now I'm going to give you a chance to write the formula for this sequence. Find the formula for the nth term of that sequence, and just as a reminder, the nth term is found that way. I'm pretty sure on the quizzes, I ask you to use a asterisk for multiplication. So I'll do that here. The shift 8. Just because an x can look like a variable sometimes, and so I think I'll have you use an asterisk for multiplication. Keep in mind what we're after here is n, and n minus 1 are going to stay as a part of our formula. We're just plugging in what's a, your starting point, what's r, your common ratio. I'm hoping that you've had enough time to write it. If you have any questions or you're not sure where this came from, just ask. But our idea here is this. Our formula for the nth term is going to start with n equals, and a is our starting point. That was 6 times r, my common ratio. Let's see, every time here I multiplied by 3. So my common ratio is 3. That gets raised to the n minus 1 power. And so the formula for the nth term here looks like that. 6 times 3 raised to the n minus 1 power. If there are any questions about that, let me know. And just to sort of illustrate the point, I'm going to find the 8th term here. So the 8th term would be 6 times 3 raised to the 8 minus 1. We're plugging in an 8 for the n because we're looking for the 8th term. And so we'd have 6 times 3 raised to the 7th power. And the idea here is we're starting out at the number 6, and in order to get to the 8th term, we're going to have to multiply by 3 7 times to get there. And so when we do that, we'll have 3 raised to the 7th power, which is 2187. So we have 6 times 2187 is 13,122. If we were asked for the 8th term here, it would be 13,122. Chances are what I'm going to ask you for is write the formula for the nth term. And then the way you would enter that, and thanks, Courtney, for being ahead of the game on this, is we're going to have n equals 6 times 3 raised to the n minus 1. And just to make sure you know where all these symbols came from, that asterisk symbol is shift 8. And this caret symbol that we use to indicate exponents is shift 6. And so the way that this would look on a quiz would be like that. 6 times 3 raised to the n minus 1. So that's arithmetic and geometric sequences and writing formulas for them. Now we're going to do a little more practice with some sequences. Here's what I mean. Find the missing term. I'll just give you a minute to figure out the missing term in that sequence right there. Figure out what that missing term would be. And when you have it, you can type this one in. I wasn't going to do a poll for this. I'm curious what you come up with for the missing term. Okay, we have a 15 there. Anybody agree, disagree? Oh, sorry. Anybody agree, disagree with that 15? Agree? Very good. All right. Well, let's think about how we get this. So we look at this sequence, and our first thought is, well, maybe it's arithmetic. So if it's arithmetic from 375 to 75, that's minus 300. Well, if I subtract 300 again, now I'm in negative numbers. So that's no good. This is not an arithmetic sequence. This is not about add or subtract. So let's try geometric. Let's see if this is about multiply or divide. Well, it's getting smaller, so it's not about multiply, but it could be about divide. And as I look at this from 375 to 75, now I have no idea what 375 divided by 75 is, but I could do the division. 375 divided by 75, that's 5. Okay, so maybe this is divide by 5 to get to the next one. And if that's true, I would try that and divide by 5 again. 75 divided by 5. Okay, that's 15. So I feel pretty good about 15, but I'm not 100% confident yet. I get that it works so far, but let's make sure it works all the way to the end. If I put a 15 in there and divide by 5 again, sure enough, we land at 3. So what we found out here through a little bit of a process of elimination, it wasn't arithmetic, maybe it's geometric. Sure enough, it is geometric. And now that I have this geometric sequence, I need to figure out what the common ratio is. And well, basically what I'm doing every time is divide by 5. Divide by 5. So if I took a number and I divide it by 5, what is that going to look like if we write the formula for this? Let's see here. It's a geometric sequence, so I know it's going to be n equals a times r to the n minus 1. Little bit difficult here to come up with our r. What is my common ratio? Because the common ratio is what I multiply by each time to get to the next term. So this is a little bit sticky here with that ratio. So I know it's going to be n equals the starting point times something raised to the n minus 1 power. The tough thing is, what is that something going to be? What's the common ratio here? It's something that we'll talk about later on in the course for sure. Divide by 5, 5 over r, okay, that will work. And so there's 2 different ways you can write this and be correct. We'll start with what they've suggested there. This is multiplication. If we want to write this as division, this is going to be 375 divided by 5 raised to the n minus 1 power. And that's okay. There's nothing wrong with that, but I'm gonna tell you what I like a little bit better than that. There's nothing wrong with what we just wrote. It's absolutely correct. Technically, you'd need a second set of parentheses here, but I'm not gonna hold you to that because, again, this is when if you're writing it on paper, I could easily see your answer. Typing it in comes with some limitations. So we're gonna do 375 divided by 5 a certain number of times. So that's what we would be looking at there. Hear me out on this. Dividing by 5, and like I said, this is something we're definitely going to talk about later in the semester, but we'll lean into it a little bit here. If I divide a number by 5, so if I say, let's say 30 divided by 5, I get 6. If I had the number 30, and instead of dividing by 5, I multiplied by 1/5. Well, we've got to remember a little bit about fractions, and that's why this will come up later in the semester, but it's a good little chance to preview it. If I multiply fractions, so I need to write 30 as a fraction, so that's 30 over 1, and then multiplying fractions, that process is multiply numerators, that's 30, multiply denominators, that's 5, and then divide at the end. And I get the same answer, 30 divided by 5. And what I'm pointing towards here is this. that dividing by 5 is the exact same thing as multiplying by 1/5. And so dividing by 5 is the exact same thing as multiplying by 1/5. These two are the same as each other. So the way that I could write this formula using multiplication instead of division is I could say that the formula for the nth term here is n equals a times 1/5 raised to the n minus 1 power. Now, you might not think that looks any better than this one down here. I'll tell you the reason I like it better is because anytime we have a geometric sequence, we just know we're going to write it as multiplication. And so we have 1/5 raised to the n minus 1 power. That's the reason I like it better. If you were to type it this way on a quiz or an exam, you would get credit for it. If the division way is just more comfortable for you, that's totally fine. Canvas might not like the way you structure your answer. And depending on how you structure it, I might not either. It has to be correct. You can't put a times here and then have it be times 5 because that's not true. We're either going to multiply by 1/5 raised to the n minus 1, or we're going to divide by 5 raised to the n minus 1. So it's not like you can type anything you want, but I'll be a little forgiving when it comes to formatting of what you have to type. The key here, the main thing I want you to notice is we're dividing by 5 each time. That's a geometric sequence. And then since dividing by 5 and multiplying by 1/5 are the same, we can write our geometric sequence this way with our common ratio being 1/5. That one's a little challenging. So if you have questions you want to ask, let me know. We've got a couple more I want to do find the missing term on. All right. Find the missing term. What's the missing term in that sequence? And essentially what we're doing here is we're looking at, we're still looking at sequences. We're just, instead of finding the next term or finding a formula, we're figuring out what's missing. Once you have it, you can type it in there. I wasn't going to do a poll here. Once you have a missing term, you can type it in there. Courtney and Moylan, all right. And anybody else who has it, it's great to type it in. This is a way for me to know. Our polls have gone really well today, so I'm pretty confident about where we are, but it never hurts for me to get more information. Great, all 52s. Emily's, that's perfect. And with this one, we see +7, +7 again. So I feel pretty confident in the +7 being my common difference, which makes this an arithmetic sequence. And then we add 7 again to land on 52. If we wanted to write a formula for this, it's an arithmetic sequence. So it's a plus d times n minus 1. And so this would be n equals a, my starting point, plus d, my difference, which is 7 times n minus 1. If anything there doesn't make sense, or you're not sure of it, or you're not comfortable with it, don't hesitate to ask. Outstanding. Okay. Find the missing term. Figure out what's next in that one. At first glance, you might call this a trick question, and maybe when I'm done with it, you'll think, that's not right. That's a trick question. It's something I want to make sure you're aware of. So maybe right now it's a trick question, but just know that down the road, because we talked about it now, you won't see it as a trick question. But I do think you can figure out the term that's next. So if you're able to come up with the next term in there, let me know what it is. Or excuse me, not the next term, the missing term. You can come up with the next term if you want, but what I'm after is the missing term. Nothing yet. Okay. Now this one, I want you to think of kind of like a puzzle and see what you can come up with. I won't leave you. I won't leave you hanging out to dry, but I want to give you a chance to try and solve it. It's one of those that I think you can do it. Dulcie says 37. We've got a guess. That's good. We're moving in the direction of talking about it. Would it be 37? Okay, we've got 237. So let's go with that. Let's see if it is 37. All right, as I look at this, all right, first I want to see if it's arithmetic or geometric. So that's -5, that's -6. Okay, so it's not arithmetic. Maybe it's geometric. What's 55 divided by 50? 1.1. So if I do 50, we do divide by 1.1. If we do 50 divided by 1.1, that's not 40. Okay, so it's not that either. What happened here is we ran into a sequence that's 100% legitimate sequence, but we tested to see if it was arithmetic, and it was not. We tested to see if it was geometric, and it was not. This is neither. And you might run across a couple that are neither. One thing I'll tell you is we're not going to write a formula for a sequence that's neither. We're going to write formulas for arithmetic and geometric. We're not going to write formulas for neither. But we can find the missing term here, and let's see. We had -5, and then we had -6. Well, let's just see if the pattern here happens to be -7. That would land us at 37. And then continuing this pattern, the next one ought to be -8. 37 minus 8, sure enough. How about that? The missing term would be 37. Excellent work, Dulcie, Courtney, Leslie. That's terrific. But a trick question for right now, yes, I'll grant you that because we hadn't seen one that wasn't arithmetic or geometric yet. But finding the missing term in here based on the pattern that exists is something we can do. We're not going to write a formula when it's neither. Let's do some practice. And I didn't want to set up polls for these because I wasn't exactly sure what my wrong answers would look like. I would rather just give you a chance to try it. So essentially, I'm just going to be patient here, and I want you to do both things. Determine whether it's arithmetic, geometric, or neither, and if possible, meaning it's arithmetic or geometric, find a formula for the nth term. So we're looking for the formula for the nth term, if possible, for that sequence. And I'll just kind of wait maybe a minute or so, and then we'll see where you are and we'll talk about it. If somebody has something that they want to type in that's, well, here's what I've determined so far, that's great. That's no different than if we were in a classroom and you raised your hand and I said, yes, Courtney, yes, Moylan, tell me what you're thinking. There's the same idea here. And we have a couple of neithers. Very good. Emily also. Perfect. All right. So we look at this and, well, is it arithmetic? Well, +1, +2, +3. Hey, that's not arithmetic, but I think I can figure out the next term. I bet the next term is 12. and that would be correct. Just to double check, let's make sure this isn't geometric here. Let's see. If I did 3 divided by 2, I'd get 1.5. If I did 5 divided by 3, I would get 1.6. Okay, so it's not arithmetic, it's not geometric, so this is neither, and we're not going to come up with a formula for that. So Courtney, Moylan, Emily, perfect. If we wanted the next term, plus 1, plus 2, plus 3, plus 4, 12 is a good answer for the next term. But as far as a formula, we're not going to come up with one because this is neither arithmetic nor geometric. All right, try that one. Determine whether it's arithmetic, geometric, or neither, and if possible, find the formula for the nth term. We're going to do a few more of these. We don't have to be in a hurry. I want to give everybody a chance, but I'm not going to set up polls. We'll just kind of talk about them together. I was thinking when we talk about these, we'll talk about them in stages. So even if you come up with the formula, don't type that in yet. You can type in whether it's arithmetic, geometric, or neither, but hold off on typing the formula because I want to give everybody a chance to do that. Okay. Courtney Moylan say arithmetic. Let's see how they got that. So 51 to 47, that's minus 4. 47 to 43, that's minus 4. So we have a common difference. The formula for an arithmetic sequence looks like this. So take a couple of minutes, well, don't take a minute or so and try to write the formula for this arithmetic sequence. We've determined it's arithmetic. That's great. Now let's try to write the formula for it. I want you to try, and then we're going to do it together, and then you can let me know if you have any questions. And I will turn you loose to type it in here also. I just want to give everybody a chance first. Typing it in is great practice, because then you get the formatting down. And just off the top of my head, there's at least 2 ways you could type this in and be correct. And that'll be just fine. But okay, if you're ready to type in the formula for this arithmetic sequence, you can go ahead and do that, and then we'll talk about it all together. If anybody has questions about how to come up with it, please don't hesitate to ask. What you'll find is there are a couple of problems about this in the book, but there's a worksheet on sequences in the modules that will give you more practice. But if you're ready to type it, you can. The formula for this arithmetic sequence. Or if you have questions and you're kind of stuck, that's okay too. It's really good, Courtney, but I don't think you want that raise it to the power in there. Because this one's arithmetic, not geometric. Same thing, Nicole. All right, these are looking pretty good. And I'm seeing both ways, which is good too. All right, let's take a look here. So we can tell by looking at this that our starting point is A, and our common difference, this time it's a negative because it's subtraction. So our common difference is -4. And you've got, is -4. You've got 2 ways you can handle that. One way you can write this and be correct is to say n equals, let's see, my 5 didn't write. How about my starting point is 51, and my d, my common difference, is -4. How's that? That's better. Now when I go to write this, n, meaning the nth term, is the starting point, plus my d here is -4. I'd put that in parentheses just to make sure the negative sign doesn't get kind of lost with that positive sign, times n minus 1. And so what we've done here is we have said that the starting point plus the common difference multiplied that many times. And that's A great way to write this answer. Another completely valid way to write this answer that most of you used is instead to sort of blend that subtraction right into the formula. And you have n equals 51, which is the starting point, minus 4 times n minus 1. And that's just fine also. Using subtraction here is just fine because that's what we're doing. We're subtracting each time to get to the next term. So either of these is a perfectly good way of writing that the formula for the nth term for that arithmetic sequence. Let me know if anybody has any questions about what we did there. Formatting can be a little sticky and a little difficult. Try to be patient and careful when you type them in. Some things are forgivable, some things are not. If you were to type this in and drop an exponent in there, well, now I can't give you credit because we don't raise anything to the power when we have an arithmetic sequence. So there's a little flexibility with formatting, but make sure you haven't done anything that clearly makes your answer incorrect. Let's try another one. Determine whether that's arithmetic, geometric, or neither, and then find the formula for the nth term. And we'll do the same thing we did last time. We'll take a minute or so to figure out if it's arithmetic, geometric, or neither. We'll get that established, and then we'll write the formula for the nth term. Okay, we've got some geometrics. I'm good with that. We're calling this one geometric. Let's see. Looks like multiply by 5, multiply by 5. So that's going to be our common ratio. And remember, the formula for the nth term for a geometric sequence is a times r raised to the n minus 1 power. So I'll give you a minute. Don't type it in yet. We'll give everyone a chance to try to type this one. This geometric sequence that starts at 8 and has a common ratio of 5. And hold off just a minute so everybody has a chance, but I feel pretty good about our prospects on this one. All right, if you're ready, you can go ahead and pop that in there. I'm guessing a lot of you typed it and just waited to send it, which is awesome. Yeah, you can go ahead and type it in and we'll see what we have here. Excellent, those look terrific. Those look terrific. Fantastic. This is something that can be hard for students, and we're doing a fantastic job with it today. I'm thrilled. So our nth term here is a, our starting point, times r raised to the n minus 1. Oh, how about I don't use r? How about I put what the ratio is in there? 5 raised to the n minus 1, and everybody use parentheses around n minus 1. That's beautiful. So there is our formula for that geometric sequence. All right, I want to do one more. And that's this one. Same idea. Determine whether it's arithmetic, geometric, or neither, and if possible, find the formula for the nth term. Hold on a minute. We'll give everybody a chance to decide whether this is arithmetic, geometric, or neither. And then depending on that result, we may or may not find a formula for the nth term. If we tried to call this arithmetic, subtract 600, subtract 600, no, that didn't work. And so then we tried geometric. What'd you come up with? Arithmetic, geometric, or neither? Very good, Courtney. And I'm sure others are with you. This is geometric. So what we're after is that the nth term is a times r raised to the n minus 1. That's our generic formula. Take a couple of minutes to try to write this one. it's a little bit challenging because it gets smaller as we go from left to right. So this one doesn't have multiplication in there. Instead, we are dividing by 4 each time. And since we're dividing, that changes things. Hold off a minute or two. We'll give everybody a chance to write this one because I would say that the most challenging formulas to write are geometric when they get smaller from left to right, when they have division involved. You can write it with division, or you can write it as multiplying by a fraction. Either way is correct. I lean towards multiplying by the fraction just because it keeps the consistency of multiplication, but it's okay if you really prefer the other way. All right, let's see what you've got there for this geometric sequence. Y'all can pop them in and we'll take a look. Outstanding. The use of parentheses is terrific there. And Courtney's is a perfect example of technically she's raising 4 to the n-1 power. I would absolutely let Courtney's answer be correct on a quiz or an exam. So that's important for y'all to see it so that you know it, because, you know, letter of the law, you're supposed to do the exponent before you do division. But I know what Courtney means here is 800 is a starting point. 1/4 is her common ratio. So it's a perfectly fine answer. It looks like everybody went the fraction way. And what we decided here then is the starting point was 800. The common ratio is 1/4. And so when we write that formula for the nth term, we have 800 times r raised to the n-1. And I put parentheses around the 1/4 because we want to make sure we're raising 1/4 to the power instead of just the 4. Oh, I knew what you meant there with the 8, Leslie. I got you. Thanks for the correction, though. That works. I'm not sure I understand the question, Leslie. Can you rephrase it for me? Or you can turn your microphone on and ask it if you want to. Essentially, what we're doing here is we're saying that dividing by 4, oh, maybe I got it. Maybe that dividing by 4 is the same as multiplying by 1/4. That's how we get to using 1/4 there instead of the 4. Dividing by 4 is the same as multiplying by 1/4, and this would be consistent regardless of what our number was. If we were dividing by 9, that's the same as multiplying by 1/9. If we were dividing by 20, that's the same as multiplying by 1/20. And that's essentially just the idea that if I say, if I divide something by, so let's look at 800 here divided by 4. If I say 800 divided by 4, that's the same thing as 1/4 times 800. Excellent question, Leslie. So 800 divided by 4, you know how you would put that in your calculator. You do 800 divided by 4. What a fraction means, really, and I don't think this gets talked about enough, but 1/4, what that fraction means is 1 divided by 4. That's what that means, is 1 divided by 4. And so if you wanted to do 1/4 times 800 on your calculator, what you would do is you would do the 1/4 part first, which is just 1 divided by 4. And that would give you a decimal on your calculator. And then you'd multiply that by 800, and you'd end up in the same place as if you did this, 800 divided by 4. But yeah, the 1/4 is really just 1 divided by 4. That'll give you a decimal. Multiply that decimal by 800, and you'll end up in the same place as you would with dividing. Yeah, very good. Well, we're going to spend a lot of time on fractions in sort of the I don't know, in the last third of our semester, don't be intimidated by it. We're gonna make sense of them and make them have fun. And you can always ask questions when you have them. But yeah, if you see 1/4 like that, that's just 1 divided by 4. And so if we wanted to plug in here, let me get rid of some of this stuff. If we wanted to plug in here and say, okay, well, I see your 1/4 there, but I don't know what to do with that. What if we wanted the, I don't know, 7th term? If we wanted the 7th term in this, well, let's see here. That'll be 800 times 1/4 raised to the 7 minus 1. So that's 800 times 1/4 raised to the 6th power. And so what we would have to do here is do 1/4 raised to the 6th power. And so we do 1 divided by 4. And so on my calculator, and I'm going to squeeze this in over here in the corner, I'll have 800 times that 0.25 sitting on my calculator raised to the 6th power. Oh, this is a good one. If we want to raise something to the 6th power, my calculator has a squaring button. You might even have a raise it to the 3rd power button, but you probably don't have a raise it to the 6th power button. What you do have, though, is a button that's either y to the x, x to the y, or a caret. And that just depends on the calculator you have. But you should have one of those buttons. What that button does is allows you to take any number you want and raise it to any power you want. Take any number you want, raise it to any power you want. And so that's what we want to do here. We want to do that 0.25 that's sitting there on our calculator. We are going to, and depending on what button you have, mine has x to the y, 6 equals. And so 0.25 raised to the 6th. And when I do that, I get a really, really, really tiny decimal. It's horrible and ugly. 0.000244, and it keeps going. Where I'm at in my problem now, back to this guy, is now I've got 800 times that horrible decimal, 0.000244. I should have done an earlier term. I'm going to in just a minute. 244. We multiply by 800, and I end up with 0.1953, and we'll leave it there. That's ugly. Stick with me for a minute. I'm going to pretty this up. Let's say we want to define the 4th term of this sequence. Dividing by 4 over and over again, the numbers get really small really fast, and so it just got a little ugly for us. Let's clean it up a little bit so that that's not the last thing you're left with here. So let's say we're looking for the 4th term in this sequence. So we'd have 800 times 1/4 raised to the 4 minus 1 power. So we'd have 800 times 1/4 raised to the 3rd power. I'm still going to do that on my calculator. 800 times 0.25 raised to the 3rd. Raising it to the 3rd power, I'm going to use my x to the y button. So I'm going to have that 0.25 x to the y button, 3 equals. That's going to raise 0.25 to the 3rd power. And I do get a really kind of not very attractive looking small decimal answer. That takes me to 800 times 0.015625. I'm out of space. Last thing I'll do is multiply by 800, and then I get something that's not so hideous. 12.5 would be the 4th term. Perfect, Leslie. Yeah, perfect. Your job, primarily in these, will not so much to be to find a horrible 4th, 5th, 7th term like that. Instead, it's going to be find the formula for the nth term, and that's what we had here.